All right, we'll go ahead and get started. Hello, welcome everyone. Thank you for joining today's webinar, Global Security Challenge, a Single Certification Solution. Just a few logistics before we jump in. The webinar will be recorded and made available on the Connectivity Standards Alliance website. If you do have questions throughout the presentation, please do submit them to the Q&A box. At the end of the session, we're going to open it up for Q&A. You can also reach out to us at help@csa-iot.org for any other questions. So at this point, I would like to introduce today's speakers. With us today is Steve Hanna. He is a distinguished engineer at Infineon Technologies. On a global basis, he is responsible for IoT security strategy and technology. And as a security expert, Steve is a leader in many standards groups. Within the Connectivity Standards Alliance, he is a director on the Alliance's board, the chair of the Product Security Working Group, and a leader of several Matter security teams. And before I hand it over to Steve, here's a quick overview of our agenda for today. We will kick it off with a welcome and introduction, review the rising expectations for IoT security, the Alliance's global approach, how you would obtain certification, a look into the future, and then we will close it out with summary and Q&A session. So with that, I am pleased to hand it over to Steve to start our introduction.
Thank you, Grace. I appreciate your help there. So welcome everybody to the webinar. And let's start off with a little introduction to the Connectivity Standards Alliance. You can see here on your screen on the left-hand side a list of the member companies, specifically the board member companies of the Alliance. You can see the members of the board include many, many leaders in the IoT world from around the world. And the Alliance is dedicated and focused on making the simple complex, on creating IoT standards that will enable all objects to securely connect and interact. We have multiple standards available from the Alliance that have been created by our members, and we provide testing and certification for those standards in addition to development of the standards and outreach regarding them. So on the left-hand side of this slide, you see an illustration of the different working groups of the Alliance. You may be familiar with the Matter standard already. This is a standard for smart home interoperability, which has really taken off in the last few years. And of course, the Zigbee standard, a low power communication standard, which has been around for more than 20 years. You may not be so familiar with some of our other standards and working groups. Health and wellness focuses on health and wellness applications within the home. Aliro on entry to buildings. And then we have a data model working group that provides the underlying infrastructure needed for these other standards groups on top of it to work. Now, the group that I'm going to talk about today is product security. As you can see there, it is one of the foundational working groups for the Alliance, and it's complemented by a data privacy working group. The Product Security Working Group recently announced our first version of our IoT device security specification and certification program, and I'm happy to be able to tell you more about that today. Of course, we're happy as well to have members from China, from Europe, and around the world. In fact, we've just announced a new Japan interest group, which will allow our Japanese members to engage with each other and to talk about issues related to the Alliance. You can see in the upper right-hand corner that we have roughly even distribution among the Americas, EMEA, and Asia for our member company headquarters, which is fantastic. And we have a good distribution as well across different sectors of the IoT world, IoT device manufacturers, ecosystem and other platform makers and retailers and silicon providers. So we really get great perspective from all around the world and all the different aspects of the IoT. Next slide. In addition to the standards that I just reviewed, we have a comprehensive certification program, which so far has certified more than 5,000 different products against our specifications and standards. These are designed to make sure, these certifications, that the products in question comply with the requirements of the standards so that the consumer can have a smooth and successful experience with IoT. And we have a global network of test labs around the world that are available for our members to use in order to obtain the certification. Next slide. Now, I mentioned the Matter standard before, and I think it's a good standard to talk about here, just to provide a baseline of understanding when we're talking about product security, what we mean by it. So Matter is a secure communications protocol based on IP, the Internet Protocol. And among the foundational principles of Matter are simplicity, interoperability, reliability, and security, as you see on the right-hand side. Next slide. As we developed the Matter standard within the Alliance, we included 10 substantial new security features that were not generally present and available in the IoT environment, especially within the smart home. For example, every device has a unique cryptographic identity. All messages are protected with industry standard cryptography. It's a requirement for a mandatory support for a reset feature that allows customers to delete their data. I won't go through all of these, but I will just say that Matter certainly raised the bar for IoT security. And what we're here to talk about today is something actually different and distinct from Matter and from protocol security in general. This slide illustrates the difference between secure communications protocols and secure products. I like to use the metaphor of building a secure banking system. For after all, the data that we have in our smart homes is equally as valuable as cash. Now, if you're trying to build a secure banking system, you need to have secure armored cars to transport the cash among the different branches and banks and that sort of thing. That's certainly needed, but you also need to have secure bank branches with vaults and bars on the windows, security cameras, and guards. And if you have both of those things, then the cash can be well protected. If you only have the secure transport, then you leave the cash in a camping tent overnight. It probably won't be there when you come back in the morning. So really, you can see that you need both of those things. And the same is true in the Internet of Things. We don't just need secure communications protocols like Matter. We also need to have secure devices. So any device that's in my home, whether it be a light bulb or a security camera or a door lock, it needs to have security measures built in. And the same is true for the cloud and also any apps or other controllers that I might be using in my home. The reason why is that we want to make sure that consumer data is protected from the time that it's generated through its processing, presentation to the user, throughout its entire life cycle. And it's not enough just to protect it while it's in transit across the network. That's important, but not adequate. We also have to protect it when it's at rest or being computed and processed on one of these other systems like the cloud, the app, or the device. And that's where product security comes into play. Product security is all about making sure that those products, devices, clouds, apps, gateways, and the like, are themselves secure. Not just communicate securely, but have built into them the ability to store your data securely, to process it securely, to make sure that if bugs or vulnerabilities are found in software, that those bugs or vulnerabilities get patched. And these sorts of mechanisms that are best practices for IoT product security. They're not required by a communication standard like Matter necessarily, but they are necessary in order to build a secure IoT system. Next slide. So what we see across the world and across the industries is rising expectations for IoT security. Next slide. Attacks on IoT systems continue to rise. I'm sorry to say this is the case. And this is one of the things, probably the main thing that's driving the strong demand for better IoT security. We see a 400% growth in malware attacks on IoT from 2022 to 2023, 4 times more. And this trend of exponential increase has been going on for more than a decade now. I'm sorry to say, truly sorry to say, as somebody who's been working in the IoT security field for more than 20 years, that it seems that the oldies are the goodies, that the oldest attacks are the most popular. If we look at the attack toolkits that are in use in the field today, we see that Mirai, the granddaddy of all IoT attack toolkits, is actually the most popular. Mirai includes software for building and enslaving networks of millions of infected IoT devices, and then controlling those and using them for distributed denial of service or DDoS attacks. Mirai was launched way back in 2016 and had a huge impact at that time when they were able to bring millions of devices to bear on a variety of targets, such as banks and essential critical infrastructure for the internet, such as domain name servers. Today, we see that 91% of attacks come from that Mirai malware family, and 87% of the top exploits that are used are more than 3 years old. So it's really a sad state of affairs when an exploit that's been known for more than 3 years can still be taken advantage of. That shouldn't be the case. And you can see the source of the information on this slide is given by the report at the bottom of this slide, noted there, the Zscaler report. So how does a distributed denial of service attack work? Well, the first thing the attacker does is to enslave those devices, and then they control them, boom, so that they all target one system at the same time. They all attack that system at the same time. I like to use the analogy that it's like being stung by a bee. If you're stung by one bee, that's really painful. But if you're stung by 1,000,000 bees at the same time, that's deadly. Your heart stops, you're dead, you're poisoned. And the same thing happens with almost any target that these distributed denial of service attacks go after. They're able to bring to bear millions of devices. And even if each device just sends a little message to that target, if they do it in a synchronized manner, they can bring that target down and render it unable to communicate at the very least, basically force it offline. And that's what happens with Mirai and what's been done over and over again. They go after all sorts of different targets. In fact, the operators of these Mirai-based toolkits or botnets will often rent out their botnet by the hour to people who want to do extortion or some other malicious attack. And then the person who's renting the botnet will use it to attack whatever their favorite target is. It's an awful thing, and we can't really have it continue. Next slide. And this is the conclusion of many governments around the world. As we look around the world, we see dozens of governments that are developing or have already developed IoT cybersecurity rules and regulations and standards, some voluntary increasingly more and more of them mandatory, and they often reference the same standards, such as ETSI EN 303645 or NIST IR 8425. So we see these governments responding to this threat of IoT botnets and distributed denial of service by saying, if you want to sell an IoT product in our country, it has to meet certain cybersecurity requirements. Not a very high bar, but a reasonable bar. So that's a very interesting development that we've seen over the last 5 or 6 years. If you look at the report listed at the bottom of the slide here, which is available from the Alliance website, you can see some more details, several dozen pages of details about these government requirements in place now or coming soon. Consumers are also concerned about IoT cybersecurity. And in fact, they say that security and privacy are absolutely essential attributes when they're shopping for an IoT device. 84% of consumers rate security as important or very important in their purchasing decision. And all of those surveyed, according to that same Omdia report, said that they would be more likely to purchase a device if it has a privacy and or security label. And who do they look to for these labels? They look to industry standards groups as the ones that are best able to define what should be included and to provide those labels. So the Alliance is stepping up to the plate, so to speak, in responding to this consumer demand. Next slide. So what are we doing for product security? We're taking a global approach. We recognize, because of our global membership, that the requirements in these different countries all need to be considered. Most of our members ship their products globally, and so they need to have a way to comply with all of these global requirements and to do so in an affordable manner. So we in the Alliance have created a product security certification program based on those prevalent standards from the US, NIST IR 8425, from Singapore, their cybersecurity labeling scheme, and for many, many different countries, ETSI EN 303645. These are the primary standards in these areas, and they're the ones that we have used as the basis for drafting and creating our product security certification program. We recognize that there are more requirements and regulations coming, and we're certainly engaged with those development efforts around the world through our members, whether that be, say, the Cyber Resilience Act and Radio Equipment Directive in Europe, or the PSTI in the UK, or any one of the others that are being developed in Japan and India and Australia, and so on and so forth. We believe that it's essential that manufacturers be able to comply with those standards and to do so in an affordable manner. And the best way we see to do that is to create a single global product security certification program aligned with the requirements of those standards so that manufacturers can certify once and qualify everywhere. That is our goal. Now, what is this mark that you get when you complete our certification program? You can see it on the right-hand side of your screen. It basically is a little logo that indicates to the consumer that this product has been verified with respect to product security by the Connectivity Standards Alliance. And if you get your product certified, you can proudly display that logo on your product, on your box, on your website, wherever you might choose to display it, on store shelves. It's really up to you. We do not require that you display the mark. That's up to you, but you can display it. We also have on our Alliance website a list of certified products, and we will provide to you a QR code that can go along with this product so that you can let the consumer scan it to get more information about your product security certification. And it'll take them to the Alliance website, to that page, and they can see, yes, certified on this date, and so on and so forth, all of the details. If you prefer instead to do it on your website and instead of a QR code, just have people clicking on a link, that's up to you, or to omit that QR code or hyperlink as you see fit. We're not going to tell you as a manufacturer how to use this mark, but we make it available to you once you complete the certification program. Next slide. So just to remind you, as I did a few minutes ago, that this is not about protocol security. This is about product security, making sure that those products are themselves secure. And just to make an additional point here, you don't need to implement Matter in your product to get this certification. You don't need to implement any of our standards, interoperability standards like Zigbee or Matter or any of that in order to get this certification. Of course, it's great if you do. I think Matter is fantastic, but if you don't, and you got a product that's been out for a few years and it has your proprietary protocols, that's fine. As long as you meet the requirements for product security, you can get the product security certification on your product. Next. So the benefits of this program. For consumers, it gives consumers the ability to identify which products are properly secured and choose those products. To have a single global certification that they can look to that gives them confidence in the security of the products they're buying so they can sleep well at night. For manufacturers, this can help to put to rest any consumer concerns about IoT product security and unleash the tidal wave of consumer demand that seems to be held back by those concerns about security and privacy. It helps manufacturers who are already doing the right thing to by providing good security in their products, helps them to get recognition. After all, we should reward manufacturers who are doing the right thing. And it makes it possible for them to have an impartial measure that demonstrates that their product does have good cybersecurity. And it provides a cost-effective way for the manufacturer to have their product qualify in all these different countries where the mark is relevant, and thereby avoiding excessive costs. They can even leverage pre-certified hardware or software subcomponents to reduce their effort even further. And regulators, well, they get more products on the market that comply with their standards and regulations. So that's a good thing from their perspective. It's a win-win-win, really. We're able to advance the state of the art in IoT product security in an affordable manner and thereby achieve our common goals of reducing security incidents by using certified products. So let's look under the hood now and get a little more information about how all of this works. So the certification process, as illustrated on the next slide, involves a few steps. If you want to get your product certified, first you need to join the Alliance and request a vendor ID, which is just a number assigned to you as a vendor. Then you choose one of the test labs and complete the testing process with that lab. Submit your application to the Alliance where it's reviewed and checked with the lab. And if you're approved, you'll be able to obtain the verified mark and have a web page for your product added to the Alliance website. Now, if you don't mind, next slide. So if we look into what are the requirements of the Alliance product security certification program, they are listed and defined in the IoT device security specification available at the URL given on this slide, or just by going to our website, csa-iot.org. This specification includes definitions, as well as a list of technical and non-technical requirements, and mappings which show how those requirements are derived from the NIST, ETSI, and Singapore specifications I described earlier. We do have some more detailed documents, such as our assessment guidance and our evaluation questionnaire, which are only available to members and which give more information about exactly how one can demonstrate compliance with the requirements described in the specification. But all of you can go and look at the specification now. And those of you who are members can take a look at the assessment guidance, see an example and some best practices, and then start completing your questionnaire. Next slide. So let's look at a typical requirement. 5.4.3.1 in our specification says data input into the IoT device via network and any other interfaces shall be validated against malformed input. Now, that's a really important requirement. I think any security professional would agree with that. Common form of attack is for the attacker to send some malicious input and see if they can get the device to, say, do a buffer overrun or otherwise fail in some manner that it allows the attacker to gain access and maybe even run their code on the device. So that requirement is based on a NIST requirement called interface access control, and it's also based on an ETSI requirement in their section 5.13-1 of ETSI EN 303-645. So we didn't make that up. We got that from ETSI and NIST. And if you were to look in the assessment guidance, you would see more details about and description of why, what is the motivation for including this requirement? What are some typical implementation approaches? What evidence is required to demonstrate compliance? What are the circumstances under which non-compliance might be acceptable? And an example answer. And if you looked in the questionnaire, you would find blank spaces for the manufacturer to provide their justification and evidence showing how they comply, and for the evaluator to supply a verdict and any follow-on comments explaining their verdict, pass or fail. Next slide. So this slide illustrates the certification process. The manufacturer prepares a questionnaire and submits it to an authorized test lab where it's reviewed and evaluated. There may be feedback from the test lab to the manufacturer asking further questions. Then after the test lab is satisfied with the questionnaire, they forward it on to an ISO 17065 certified certification body, which reviews it. And finally, after that's been accepted, the verdict is sent to the Alliance, along with enough information that they can populate a registry and the website. And finally, the manufacturer receives the logo and the QR code that leads to the website. I want to make the point here, since many manufacturers might be concerned about their confidential information about their security measures, that this is designed to be a secure process. After all, it's in nobody's interest to have information about the manufacturer's security countermeasures, detailed information, made publicly available. In fact, it's essential that that information be kept confidential, as you wouldn't want the combination to your bank vault to be available to everyone. And so the questionnaire, as you can see, is restricted to the authorized test lab and the certification body. And certainly any feedback, such as pointing out problems or concerns about the manufacturer's cybersecurity, would be communicated exclusively between the authorized test lab and the manufacturer. And these communications happen over secure communications protocols. The authorized test labs are required to be expert in cybersecurity certification, and even to be ISO 17025 certified in that area. So they have lots of expertise with secure submission techniques, secure storage, secure processing, secure communications with manufacturers who are applying. So the manufacturer can rest easy knowing that this information is, the details of it are held confidential and will not be released to the public. But the verdict and summary information is released to the public at the end of the process. Okay, yep, and that QR code can take you back to the website. So what are we doing next? Well, I'm very excited about the future and what we have planned for our product security certification program, but I'm not at liberty to go into the details of what we have planned. So what I can say is that as we look around the world and we see, all of the standards and certification programs that are under development around the world, and we can see that there's a continuous need for adding more capabilities and more requirements. The bar is always being raised in cybersecurity, and we are planning and working to keep up with the continuous pace of development as attackers figure out new ways to go after IoT devices and new countermeasures are developed. So I expect that the product security certification program and our specification will continue to evolve to address those emerging threats and to meet the needs of governments and consumers and manufacturers around the world. Next slide. I just want to wrap up with a summary, and then we have some time here for question and answer. So to summarize, we are working hard at the Alliance to address today's IoT security problems. Well, we see that there's a growing number of IoT security attacks. The consumers are concerned about that, and rightly so. The governments are responding with IoT security requirements and in some cases mandatory regulations, which cause concerns about cost and complexity. If you have to comply with dozens of different government regulations, that could be very expensive for a manufacturer to sell their product around the world. And so in response, we've developed our product security certification program with the goal of certifying once and complying everywhere to provide a cost-effective way to verify the security of IoT products. I'm looking forward to conversations here on today's webinar and to follow up in the days to come on this topic. I encourage you to join us.
Thank you so much, Steve, for speaking with this community more about the product security certification program. Just a reminder, if you want to learn more and get involved, you can visit our website, csa-iot.org, and here's specifically the link to learn more about the product security program. And just with that, I would like to open it up for our